This is the video Introduction to Experiment 8, Potentiometric Acid-Base Titrations. You'll be doing two unknown determinations in this experiment. You're going to determine the amount of acetic acid in vinegar and the amount of aspirin in a commercial aspirin tablet. The method you're going to use for both of these is an acid-base titration with sodium hydroxide as your titrant, the same thing you did in experiment 3. This time, though, you'll be using a pH electrode instead of an indicator to find the endpoint. The two reactions of interest are given there. The top is for your acetic acid and vinegar reacting with your sodium hydroxide titrant. The bottom is for the weak acid that is the aspirin active ingredient reacting with the sodium hydroxide. To standardize your titrant, you're going to do it the same way you did in experiment 3, using KHP as your primary standard. And so for that, you'll use phenolphthalein to find your endpoint, the same way you did in experiment 3. For your unknown determinations, you don't need an indicator. When you show up to lab, this is what's going to be on your bench. There will be a pH meter with an electrode that's resting in a buffer solution, and then you'll also have a stir plate with a very tiny stir bar on it. When you turn your pH meter on by pressing the standby button, what you need to look for are those words "good electrode" on the screen. This means that the electrode is standardized and it's ready to use. If you don't see those words, it'll say either electrode error or just won't say anything. That indicates that your electrode needs to be standardized. So you can let me or the TAs know, and we'll give you instructions for how to do that. For your standardization, you're going to do the titration the same way you did in experiment 3 in a 250 milliliter Erlenmeyer flask. For the unknown determinations, though, you're going to need to set it up so that you can have a pH electrode in the solution and dispense titrant with your burette at the same time. So this is the way to do that. You'll take a 150 milliliter beaker, put it on the stir plate once you've pipetted everything that needs to be in it. You'll put the stir bar in there and arrange the burette and the electrodes so that they're both over top of the beaker. You need to make sure that the tip of the electrode is fully submerged in the liquid in the beaker, and that the burette, when you dispense a drop, that it's going to fall into the beaker. You can turn on the stirring at this point too. Start off very small. Some of the stir plates are powerful and they'll splash liquid out of the beaker if they stir too hard. You don't want that to happen. As you're collecting data with your pH electrode, so you're going to dispense 2 milliliters of titrant, read the pH. Dispense 2 more, read the pH. At each of these points, you need to write down the pH value in your notebook. So you should have a very large table of data in your notebook. The way that you know when you're ready to write down the number on the screen is when you see the word stable, like you see here. This will definitely occur near the beginning and the end of the titration, but near the equivalence point, it may not stabilize. The reason for that is that the pH is changing very rapidly at the equivalence point for an acid-base titration, and the pH electrode may not be able to keep up. At that point, the error in just picking a value and writing it down is going to be pretty small because the slope is so steep. So don't wait too long for it to stabilize if you think you're very close to the equivalence point. If you're far from the equivalence point, you should expect it to stabilize. For your reference, this is a picture of your stir bar. It's very small. A common thing that happens is that when people are pouring out their titration waste, which can all go down the sink for this experiment, they pour out the stir bar with it. If you lose your stir bar in this experiment, you're going to lose 5 points off of your data sheet. So, all of the sink drains are on the right-hand side of the sink in Chem 300 lab. Pour out your beaker on the left-hand side so that if the stir bar does fall out, you have time to grab it before it goes down the drain. Your data analysis is straightforward for the standardization part, and you're going to need to do something you've never done before in Chem 300 for the unknown determination part. For the standardization, it's the same thing you did in experiment 3. You weigh out some KHP, you use the mass of that KHP to figure out the number of moles of primary standard, use the number of milliliters of sodium hydroxide that you delivered to the beaker to find the concentration of sodium hydroxide. What's in your bottle now should have a concentration written on it from experiment 3. It's about 0.1 molar. For this experiment, you need 0.05 molar. So before you standardize it, you'll need to dilute it in half. That's why we're standardizing it again. For your unknown determination, Your data analysis is going to be done in Microsoft Excel or a similar spreadsheet program. In the lab, you're going to collect data points, volume and pH. You're going to plot these at home, put them in a spreadsheet and just plot them, and you're going to use the bisection method as described in handout 4 of your lab manual to find the endpoint. Then you're going to make another plot, the first derivative of the pH versus titrant volume, and you're going to use that plot to find the endpoint, also as described in experiment 4. And then you'll plot the second derivative, and then also find the endpoint as described in experiment 4. What that's going to look like, so this will be what your plot of raw data looks like. So on the left is the data. It should have been in your notebook, and then you're going to just copy it into Excel. You use Excel to make a plot, which should have axis labels with units where appropriate. And then on this plot, you're going to draw some lines, the bisection method, and find the endpoint. Next, you'll take the raw data and turn it into slightly analyzed data by computing those columns that you see there, and you'll plot column D on this sheet versus column G. So this is average titrant volume added versus the change in pH over the change in volume, so the first derivative. And what you should get is a plot that looks like that. The highest point on this plot represents the maximum slope in the plot on top, which is the endpoint of the titration. Finally, you're going to plot the second derivative by computing the columns that you see there, and then you'll plot column L, in this case, versus column I. For this plot, the point where the curve crosses the x-axis represents the highest point on the plot above it, which also represents the point of maximum slope in the top plot. So these are 3 ways to find the same thing. So in the first plot, you're looking for the steepest part of the curve. The second plot, you're looking for the highest point, or the area between the 2 highest points. And in the third plot, you're looking for where the slope of the second plot changes from positive to negative. In other words, where the third plot, the line crosses the x-axis. On your data sheet, you're going to be asked to describe which of these is more reliable, so make sure that you're thinking about that as you're doing these plots.